Before learning cybersecurity, it's important to understand what exactly we are protecting and how it works inside. Think of a computer like an office. Every time you type something, click, or open a file, it's like sending a small task to that office. Let's take a quick look inside. In any office, these are the parts which are generally we see: reception desk, manager's cabin, working tables, storage room, delivery desk, and office admin, which handles all these things. So, how these things are related to a computer? Let's see one by one. A reception desk. It's like input devices where the task arrives, like from keyboard or mouse. Then there is a manager cabin. It is like a CPU, the brain that decides what needs to be done. And it's like a manager who handles all the work. Every second, they follow three-step routine. The first thing is fetch. Fetch the task from a memory. Then the second thing is decode that particular task, what needs to be done. And the third thing is execute. They tell an employee to complete it. And this happens millions of times per second in any CPU. And in cybersecurity, if someone tricks the manager to follow their instruction instead, that's how exploits and malware works. Then there comes memory. So there are two types of memory. The first thing we see, working tables, which is a RAM. RAM is fast, but it has a limited space. So it's like a table where employees keep all the files they are actively using. And then there comes a warehouse, storage that we talked about. It's like a hard disk or SSD where all the files are safely stored for later use. When the manager needs a file, it fetched from the warehouse. But unlike RAM, it is slow. But it has a huge space. So both have different responsibility. Just like when you turn off your PC, RAM forgets everything. Just like clearing your desk at the end of the day. But it's not like same for the SSD also. It's a permanent storage. If you turn off your PC, then also you can get your files and documents in that particular from that particular storage. But in the case of RAM, you cannot. Then there is a delivery desk. It's like output devices where all the finished work goes, just like a screen or a speaker from where output comes. And then who run the office smoothly? That's the operating system, like an office administrator. It decides which employee, like a program, gets to the use of CPU, how much desk space, like memory, they can occupy, and when to access the warehouse, that is the storage. Without it, whole office would be chaos. Let's see one happy flow for a particular task. Let's see, we want to see one photo which is in our device, right? We'll click on that particular photo to open that photo from a mouse, which is a reception desk input devices. That command goes to CPU. Now the photo is present inside storage room, but we know it's slow and devices are designed to respond faster, but we have working tables which are fast. A photo is present inside this storage room, but we need fast access. So with the help of operating system, that photo is made available to these working tables, wherefrom the CPU can fetch that photo and processes it to deliver. So when the photo is made available in these working tables, CPU fetch it from there and processes it to show it to delivery desk, which is a monitor. So we can see that photo in this particular monitor. So this is the happy flow which defines a task, how a task is implemented behind the scene. And this operating system handles everything, all the communication. Like manager wants to see that particular photo in this working table. So this is going to provided by the operating system, which is office administrator. So now imagine, what if someone sneaks in the fake instruction to the manager, or just steals the files from warehouse? That's how a cyber attack actually happen, by exploiting how this digital office works. Understanding this helps you think like both defender and attacker. In the next video, we'll zoom into those files and how data is actually stored inside using bits, bytes, and binary. Thank you.